So I'm going to demonstrate how to compute two types of measures of association. The first one is covariance, and the other one is correlation. Now, when we're saying the measures of association with regards to these two types of statistics, what I'm trying to do is understand the linear relationship between two variables. So there are going to be times where you just want to assess one variable and do some analysis on it. And then there could be times where you want to assess two variables together and see what the relationship is between those two. And you can do this using the covariance and the correlation. I have the formulas shown here for both the covariance and the correlation, and they seem a little bit complex, but it's important to make sure that you understand what's going on in the back end when you select the Excel functions to be able to compute these automatically. So there are Excel functions for both of these. And you'll notice that I have the formulas both for a population and a sample for both the covariance and correlation. And I'm just going to be focusing on the sample related formulas. Here, if you look at the covariance in the numerator, what we're doing is we have an x variable and we have a y variable. And for each one of these variables, we're going to get the mean and we're going to subtract the data points from the mean. And we're going to do the same thing for that second variable that's related to that first variable. So we're also going to get the mean for that second variable and get the deviations from them. And for each one of those records, we're going to get the product. So we're going to multiply them. So once we get the deviation for the first variable and the deviations from the second variable, we will multiply it. And however many records there are, however many observations there are, is however many times we're going to have to multiply them. And then at the end, we'll sum up all the results and then divide it by n minus 1, since we are dealing with a sample. For the correlation, we cannot compute the correlation coefficient unless we had the covariance already. And you'll notice this is the part in the numerator. So once we have that calculated, then we would divide it by the standard deviation of the first variable and multiply it times the standard deviation of the second variable. So you'll notice now we have x and y. One variable is considered to be the independent variable, and then the other variable is a dependent variable. Normally, this is how it's assessed when you're trying to do a measure of association, where the x variable is often going to be the variable that you'll find on the x-axis. And I have a scatter plot, and this is going to be the diagram that's shown whenever you try to compute measures of association like these two that we're talking about here. So in this scatter plot, I have two variables. One variable is related to the median SAT, and the other variable is related to graduation rate. And we're trying to get an idea and see if the median SAT rates have some sort of linear relationship with the amount of people who graduate. So we're examining two variables together and understanding the relationship. And you can see that as we increase in the median SAT score, we are also increasing in the graduation percent here. So there is a relationship. And if we're trying to figure out what type of relationship in terms of it being positive or negative, this would be an example of a positive linear relationship because as we increase one variable, the other variable also increases. The negative would be if one variable increases, then the other variable decreases. So this is going to be the data I'll be focusing on. So we have data related to colleges and universities, and we have different variables that we're recording. And we're going to be focusing on the median SAT variable as well as the graduation percent variable. And I will be computing both the covariance and the correlation. I have two worksheets, one for each. So I'm going to be computing these things manually, applying both of these formulas that we have here. And then I'll also be performing the Excel functions to compute both of these. Now, I do have some notes, and these are just really giving you a very simple, quick idea of covariance and correlation. It may be hard to interpret the covariance value, but the positive and negative sign will let you know what kind of relationship that you're dealing. Correlation is where we would get a better understanding in terms of the magnitude, the strength of the relationship between those two variables. But remember, you cannot compute a correlation unless you know the covariance. But if you have Excel and the functions, you don't have to worry about the computation of the covariance. It saves you a lot of time. But we need to understand how these things are run in the backend. So let me go ahead and focus on computing the covariance. And I have the setup here already, focusing on these two variables that I mentioned earlier. So the very first step is we have to get the deviations for both the graduation percent as well as the median. And once we get the deviations for both of those, we have to multiply those values together. And we would put that value here in column F. So I'll focus on the first record that we have, and then I'll use the fill-in option to compute the rest of them. Then I'll focus on the denominator afterwards. So I'm going to hit the equal sign and focus my attention on graduation percent right now. And I need to get this data point and subtract it from the mean. So I would need to be able to compute the mean. I can put all of this in one cell, but let's just break it down a little bit. So I'm going to go down to my data set and just compute it from here. So I'll say average, and we get the average graduation percent, right? So I got that taken care of. Let me go ahead and take care of the average for the median SAT. So we have the median SAT value here now. So I will now go into my first record and start getting the deviation for that first record. So here's the data point, subtract it from the mean, and I calculated the mean over here. So I'll select that. I'm referencing the cell, and I'm going to lock in that cell and get the absolute reference for that mean. So that cell reference will not shift down. And I'm going to use the filler option. It'll take care of the deviations for all of those. I'm going to go ahead and do the same thing for my second variable. So the median minus the mean of the median SAT, which is that. I'll go ahead and put the dollar signs before and after the letter to get the absolute reference. Hit enter, got the deviations or the deviation, and then I'll get the deviation as I use the fill in option. Now, focusing on this third column, I need to multiply this value times this value. So let me go ahead and do that. And I use the fill in option. And there we have the product of the deviations for both of these variables. Now, the next step is divide it by the sample size minus 1. So let me go all the way down, but I would need to make sure that I sum up the products that I have here. So I'll go all the way down, and here where it says sum, right now I have a value error, and that's because earlier I was working on it. But if I say sum and select the values, I now have the sum of the products that I computed in this third column. Now, for the count, I can use the count function. We know you can use either count or count A. I like to use count A, and I'll select the count. We're dealing with 49 observations. Now, to get the covariance, and this is what the goal is here. Before I get the covariance, let me just type in the covariance function here and get the result. And I'm going to assume that we're dealing with a sample. So the first parameter in the covariance function says select the array 1, hit comma, select array 2. So let me select the first array, and that's going to be the values related to graduation percent. I'll hit comma, and now select the second array, second set of values, close parentheses, hit enter. And this is the covariance value that I have. Now it's positive, it's not negative. So I'm saying that there is a positive relationship between the median SAT scores and the graduation rates. So if I'm going to compute this manually, since I am doing these steps here, I should, in this cell, I should get the same result here. So let me do that. Let me go ahead and bring this down so I can refer to it as I am trying to compute it. So the sum of the product of deviations divided by n minus 1. So here's a sum of the product of deviations divided by n minus 1. Well, here is 49. I can just say minus 1 is 48. I'll hit enter, and I get my covariance value here, which is different from the value that I have here. Okay, so I'm going to go ahead and redo this Excel function because this is what I probably did incorrectly. So I'm going to delete that and type in covariance.s, and I might have selected the wrong, or at least an additional value for the arrays. So let me focus on that. So here's a graduation percent data values. And I accidentally selected the mean, which I didn't need to include. I'll hit comma, and I will select the second set of values, not select the mean, close parentheses, hit enter. And now I have that same value. So manually I did it correctly. I included an extra value or two when I shouldn't have. I really need these values here. So now I have this covariance. It's a number, hard to interpret, but this is within the scale of the data that we're dealing with here. So because it's not that easy to interpret in terms of its magnitude, we do know the relation in terms of it being positive or negative, and we said this is positive. So we will refer to the correlation calculation to get a better idea of its relationship. So the second part is where I want to get the correlation, and I'm not going to redo a lot of this information. All I really need is to compute some of these statistics here. So let me go ahead and do this. I'm going to say STDEV, so we know this is dealing with a standard deviation. And I want to get the standard deviation, a sample standard deviation for graduation percent. And I want to do the same thing for the median SAT. And I'm going to bring this formula over to the covariance calculation. So the sample standard deviation, lowercase r sub xy, equals the covariance over the standard deviation for the x variable, and you multiply it times the standard deviation for the y variable. We got the standard deviations. So let me go ahead and type that there. So the correlation is going to be the covariance divided by the product of the two standard deviations. And this is the correlation coefficient that I get. Let me go ahead and use the correl, and this is the function name to get the correlation, and this is the shortcut method here. So this function that I'm about to run is going to compute the covariance that's needed to get the correlation as long as you select the data arrays. So let me go ahead and select data. Here are the two arrays. I'll hit enter, and now I get the correlation coefficient. And it's not really necessary to have so many decimal points on all of this. I'm just going to keep it at 2 decimal points. So our correlation coefficient is 0.56. Now, the correlation coefficient is not in the same units of measurement of our data. Correlation coefficients are between -1 and +1. So if there is a correlation coefficient that is around 0, then we're saying that there's no relationship there. But if it's closer to 1, the stronger the relationship. So we have a positive 0.56. We can say that there is a moderate relationship between the median SAT scores and graduation rate. Now, going back to the notes, we knew that was the case by just looking at the scatter plot diagram that we have here. And we were able to now put a numerical value that explains the linear relationship between these two variables using the correlation coefficient. So you saw how we did this step by step. We did this manually. And instead of me having to put all these values back in here, I decided to just keep my work all within this worksheet and compute not only the covariance, but also the correlation. So let's say, for example, we want to get an idea of the relationship between multiple variables all at once. So instead of having to use the correl function and select two arrays, there is a shortcut that you could, where if you want to look at the relationship between multiple values or multiple variables, I'm going to go ahead and select the data analysis tool feature. So let me go to data analysis, and select the correlation. Press OK. And for the input range, I'm going to select all the variables that I want to do a correlation on. And it's going to do a correlation on every single combination there is. Since we are dealing with correlation, you can only do correlations on values that are numerical. So I'm going to be selecting columns C through columns F. So for the input range, I will select these, 5 variables. I did select the labels, and I'll go ahead and just output this information in a different worksheet. I'll press OK. And this is the default output that comes out. So this is a little bit of a shortcut if you need to assess a bunch of variables and the correlations between them. So you'll notice that what it does, it first shows a series of ones here, and 1 means that there's a perfect correlation between the median SAT and the median SAT variable. So it's just doing a correlation on itself. And we're saying it's perfectly correlated. So here we have an example of a negative correlation coefficient when we're examining the acceptance rate in the median SAT. We have a negative 0.60. So there is some relationship there. It's negative. So that means as the median SAT scores are increasing, the acceptance rate at the university is decreasing. Now let's pay attention to the graduation percent. Here we have 0.56, and that's the same correlation coefficient that we computed earlier when we were examining the relationship with the median SAT variable. So this is a really neat approach to take if you want to examine relationships really quick using multiple variables.